Hi, welcome to Raw Math. Today I'm doing a series of videos on exponential and logarithmic models. The table below shows the number of people cured after a vaccine was found for an illness. An exponential growth model for the data given, where P of M is the number of sick people still sick each month and M represents the months. Note where M equals 2 corresponds to May. So this is not our initial value. All right, which month was the vaccine first administered? So if M equals 2 is May, and then M equals 1, M equals 0, this will be April, and this would be March. So our initial month would be March, counting backwards in time. Then what is the initial number of people sick when the vaccine was first administered? We can do this two different ways. We have our formula and we can put 0 in for M. So we can calculate P of 0. We would have 58,297 times e to the negative 0.11 times 0. But the thing is, when you take an exponent to the power of 0, this is going to equal 1. So what ends up happening is this number is our initial value. We don't even need a calculator for that. So we end up with 58,297 people. So we didn't really need to even write down all of that. The equation gave us our initial value right there, which was kind of nice. All right, so then the next question says, if this trend continues, how many people will be sick after a year, 12 months of administering the vaccine? So this we do need a calculator. P of 12 equals 58,297,000 e to the negative 0.11 times 12. Notice September, that's only going to be 6, 2, 3, 4, 5, 6. So our table only went up to 6. All right, if we put this into our calculator, we get 15,573.18. We can't have part of a person. People are whole people. So this becomes 15,573 people. And we always make sure to label all of our answers. And as always in math, we always do the input for output and output for input. We need to be able to go both ways. So we then say 58,297 e to the negative 0.11 m equals 10,000 to figure out in which month we will reach 10,000. First, before we can do anything with the ugly, that is e to the negative 0.11 m, we need to get rid of our initial value. So we divide both sides by 58,297. And we get e to the negative 0.11 m equals 0.171535. It doesn't really matter because we're not going to clear this out of our calculator. We're going to leave that number in there. I say the ugly, that is e, but e is actually one of the easier bases to deal with. We're going to take the natural log, which is the inverse of e. So we'll take the natural log of both sides. And natural log is a button on your calculator. All calculators have log, and all scientific calculators have log and natural log. These are inverses, and so these actually just cancel each other out. And we end up with negative 0.11 m. And this we can just hit, depending on your calculator. I do natural log of answer. For a lot of TIs, you have to hit second answer to get to it. For a lot of Casios, there's an answer button. And for really old scientific calculators, you just have that on your calculator display and you hit natural log and it'll automatically do the natural log of the thing that's on your display. Anyways, when you take the natural log of this, we get negative 1.76297. Again, it doesn't really matter how many decimal places we write because we are just going to keep that in our display and divide by negative 0.11 and get that m is equal to 16 point. And again, there's decimals, but we want to know which month that predict the first month. So we want to know which month. The initial month was March. So if we go March plus 16 months, well, there's 12 months in a year, so we subtract 12, we have the March of the next year, plus 4 more months, March, April, May, June, July. So July of the next year. All right, I hope you've enjoyed this video. Please subscribe to my YouTube channel, and I'll see you on the next video. Thanks.